Hi students, this lesson is on problem solving using verbal models. So with this lesson, in the previous lesson we worked with verbal phrases, translating them into mathematical expressions, where this lesson we're going to be working with verbal sentences and then translating them into equations or inequalities. So if you look at the first bullet here, it says there is a difference between a phrase and a sentence. The yellow highlighted part says the verbal phrases translate into mathematical expressions, whereas verbal sentences translate into equations or inequalities. So when we're writing algebraic expressions, equations or inequalities that represent real-life situations, we call that modeling, and we're going to be looking at some modeling examples in this lesson. When you write a mathematical model, there are 3 steps to help you set up and solve the problem when you're going through the process. So the first thing to do is to set up write the verbal model. You're then going to label different parts of the verbal model, and then you're going to write the algebraic expression of that. So let's start off with our first example here. It says a jet pilot is flying from Los Angeles, California to Chicago, Illinois at a speed of 500 miles per hour. When the plane is 600 miles from Chicago, an air traffic controller tells the pilot that it will take 2 hours before the plane can get clearance to land. The pilot knows that at its present altitude, the speed of the jet must be greater than 322 miles per hour or the jet will stall. So the first part of this verbal expression here, verbal model, it says at what speed would the jet have to fly to arrive in Chicago in 2 hours? So we first have to, looking at the steps from the previous slide, we have to write down our verbal model. And as the question's asking, they're wanting us to find the speed of the jet. So our verbal model is going to be the speed of the jet. The speed of the jet times the time gives us the distance. That would be our verbal model for that. Then what we have to do is we have to label. So our next step is we'll label what is in the expression above here. So the speed of the jet, that's what we're trying to figure out. We don't know what the speed is. So we'll call speed, we'll label that as x. Now our time in the sentence is going to be, it's going to take 2 hours before the plane lands. So our time here is going to be 2 hours. And then our total distance to travel, what is our distance to travel? Well, they're saying it's going at a speed of 500 miles per hour, but then it says when the plane is 600 miles from Chicago. So 600 miles here is actually going to be our distance to travel. And so with given our time and our distance, we can find our speed. So our algebraic model, that would be our third step. I'll write that over here. Our algebraic model is going to be the speed times the time equals the distance. Speed, we don't know, that's x. Time is 2. So we're multiplying 2 and x to find our distance. So, and our distance actually, we have that, which is going to be the 600 miles. So the way I write this would be 2x equals 600, and I need to find my x by dividing 2 to each side. So x equals 300 miles per hour. So that's the speed at which the jet would have to fly to arrive in Chicago in 2 hours. So that would be my answer to A. Notice I did all the steps from the previous slide. I wrote my verbal model, I labeled, and then I wrote my algebraic expression. I would want you to do that in the bookwork as well. So based on finding the speed, the 300 miles per hour, we can now answer part B, where it says, is it reasonable for the pilot to fly directly to Chicago at the reduced speed from part A, or must the pilot take some other action? Well, they're saying here within the sentence, the pilot knows that at its present altitude, the speed of the jet must be greater than the 322 miles an hour, or the jet will stall. Well, we found that the speed is 300 miles per hour, which is less than the rate then it needs to go, otherwise it will stall. So will the plane stall? Yes, the plane will stall. So 300 miles per hour, we could say, is not reasonable for the pilot to fly at 300 miles per hour, or I should say 300 miles per hour is not reasonable for the pilot to fly, because then we could just say, because the jet will stall. That would be fine. So that would be your answer to part B right there. Example 2, this expression is more of a verbal phrase versus a verbal model. It says the product of $25 and the number M of club memberships is greater than or equal to 500. Well, what we have to do is we have to, I think first here it'd be best to label, see what's in the sentence is mathematical terms so that we can write an algebraic expression here. So when we say the product of 25 and the number M, product in math means multiply. So we're going to be multiplying the $25 times the number M for their club membership. So we can write this as 25 times M. And as we continue to read the sentence, it says, the product of 25 and the number M of club memberships is greater than or equal to $500. So how would we write that? Well, we would write the greater than or equal to sign, $500. And that would be my answer to number 2. And that'll be it for this lesson. We'll continue with examples in class.